remember, we got virtual tutoring. You need help with math? It's after school time? Hit me up, HMU, and I'll help you out. You don't have to, but it's easy and it's free. Also, if you need attendance hours, maybe one day, you take too much of a vacation in the middle of the school year, you know what I'm saying? Anyways, so just FYI, that's there. Anyways, we have a quiz this Thursday. So let's talk about this warm-up. This should be a review. So if you've been here, you should know how to do this. I'm going to remind you how to do it, but make sure you're not on your phone over there. That phone, wait. Now, first let's label all the central angles. Do y'all see the 19 degrees, right? And you see it makes an X. QS, TR, make an X. So we have vertical angles that are congruent. So 19 here means right here is also going to be 19, right? Vertical angles. Now, next to the 19, does everyone see this 90-degree angle here? These two need to add up to 90. So what do I do with 90 and 19 to get this missing piece? Subtract. So 90 take away or minus 19 is 71. So this right here is going to be 71 degrees. Next question. TR is a diameter, straight line of 180 degrees, right? And I see this is 90. So what is this piece over here going to be? TUP. What's this going to be with 90 to make it 180? Somebody new, help me out here. What is this angle going to be if there's a 90 next to it and it makes 180? Is everyone looking and listening? Oh, thank you, 90. So again, TR is a straight line, 180. Take away the 90 we know. 180 minus 90 is 90. So right here is going to be 90 degrees. Right angle. Last piece we don't know is RUS, this big chunk. Once again, I see a straight line, right? Not through a little piece of paper that you rolled up. Straight line of 180. And what do I do with 19 and the 180 to get this? Once again, we're going to subtract, yeah. So 180 take away 19. 180 minus 19 is 161 degrees. Now, this is what we learned last week. If you were here, most of y'all should have been, but if you have missed some days, maybe you forgot. The central angle is equal to the intercepted arc, right? So whatever's in the center matches whatever's on the edge. So if I see 71 in the central angle, I'm going to put 71 on the intercepted arc. Okay, 19 central angle, 19 intercepted arc. 161, 161, 19, 19, 90, 90, right? The central angle matches the intercepted arc. They're always equal. So let's fill this in. What is PQ? If I follow the edge from P to Q, it's right there, right? It's labeled 71 degrees. SR, if I follow along the edge, it's already labeled here, 161 degrees. Now these next ones, we gotta add some parts together, right? Over there. Hey. Now look, QRT. If I follow Q to R all the way to T, there are 3 parts to QRT. The 19, the 161, and the 19. Can you add up those 3 parts to get the whole? Part plus part equals 19 plus 161 plus 19 gives you 199 degrees from Q to R to T, 3 parts. What about PSR? So I'm following the edge from P to S to R has 3 parts, 90, 19, and 161. So let's add 90 plus 19 plus 161. You end up getting 270 degrees. Last but not least, P to S. If I follow the edge, P to S has two parts, 90 and 19. We're going to add up those parts. 90 plus 19 is 109. 109 degrees. Okay, do you see how this works? This is just a review from last week. We're going to do some notes real quick. And when I say real quick, I mean it's nice and short. So you need to make sure you can hear me without headphones in your ears so you can get it down.
No,
What? What about the one? Can you hear? Well, that's it, right? Oh, yeah, that's it. Grab some, put up. All right, here we go. What? Yeah. What do you think? We're just gonna do notes with no worksheet. All right, here we go. Everybody, inscribed angles. Can everyone hear me? And everyone's seeing what I'm doing. Now, inscribed angles. This is vocab we learned last week. Does everyone see that this angle is not in the center? It's on the edge. Whenever it's on the edge, you call that inscribed angle. Okay, so an angle whose, go ahead and write this down, vertex is on a circle and whose sides contain chords inside of that circle. What is the name of this angle? So if you look at the edge, obviously the angle's vertex is E, right? Does everyone see that angle? E is the vertex, but you're not going to just put E. You always got to put the three letters that make the angle. So if you were to follow 3 points, what would the angle be? And it would be angle DEF. If you follow D to E to F, you get that inscribed angle on the edge. Now here's the new thing we're learning today. Is everyone locked in? Here's the brand new thing. It's one little space. Ready? The measure of the inscribed angle is half. Half of the measure of the intercepted arc. Does everyone see that it is not equal? It is half. Okay, so the central angle we learned was equal, but this inscribed angle is going to be half. That's the new thing for today. So from this little picture here, the measure of angle ABC is going to be 1/2 of the intercepted arc over here, which is AC. Okay, inscribed angle is half of the intercepted arc. Okay, let's make up an example on that picture there. If my intercepted arc was 90 degrees, what would this angle be right here if I had just told you that it's going to be half of the intercepted arc? What do y'all think? 45. How did you get that? Cut it in half, right? Half of 90 on the outside gives you the edge inscribed angle, so it'd be 45. Okay, so that's just a random example. Let's do 3 examples real quick, and we'll be done with the notes. Here we go. Does everyone have that down? Example number 1. I'm going to put an X for what I'm missing. I'm missing measure of angle ABC. A to B to C. Put a little X there. Why not, right? That's missing. Any ideas? How do I figure out X if the intercepted arc is 120? It's half, like we just said. What's half of 120? 60, right? Now, I'm going to show you the algebraic way to set it up, but I don't mind if you can mentally just divide things by 2. That's actually great, okay? But here's how I would set it up. The inscribed angle, X, equals the intercepted arc divided by 2. What is 120 divided by 2? Well, it's 60. Does everyone see how we figure it out? If you're given the arc, then the inscribed angle, you just divide it by 2. That's it. Easy, right? Example 2, though, is where people mess up because they don't think. So I want you to think. Do you see how example 2 is different? Instead of being given the arc, now you're given the inscribed angle. So you're going to have to think backwards. Any ideas? How do I figure out DF, the arc? You say add? Times 2 is correct, okay? The opposite of dividing by 2, half, is multiplying by 2. Cool? Make sure you're looking over here. It's brand new stuff. So for example 2, here's how I would set it up. What's the inscribed angle? 35. Equals, what's the intercepted arc? I don't know. I'm going to call it x divided by 2. So again, if you set it up algebraically like this, how do I get rid of a divided by 2? What's the opposite of dividing by 2? Like we just said, multiplying by 2. So times 2 cancels out. 35 times 2 is what? 70 is x. Okay, so again, if you divided 35 by 2, do you see why that's wrong? Because you're not given the arc, you're given the angle. Okay, last one, mental math. If the arc is 60, what's the inscribed angle? $30, right? 60 divided by 2 is 30 degrees. That's it, okay? Now, the only thing that might be a little tricky is when there's some algebra involved, but I'm going to let y'all figure that out. If you don't, hold on to it, because tomorrow you have some time to work on this assignment too. Today, your priority, given your little grade sheet, if there's any 1s on there, those missing assignments, you need to do those first. If I gave you any papers back, you want to fix them, turn them back in. If you're done with everything from last week, then I want you to work on this. You have today, but also tomorrow, you can work on this too. Tomorrow is an early release day, so we do have class, come to school, but it's a shorter class, right? All right, here we go.